Here's our warm-up for today. Triangle EAB is similar to triangle DAC. Determine if the statements are true or false. So it's not multiple choice. You're just doing number 1, true or false. Number 2, true or false. Number 3, true or false. Number 4, true or false. Okay? Oh, gotcha. Number 2, true, false, true. Teaches me not to trust my students. Okay, let's explain why this is true. Okay. AD is to ED as AB is to BC. That is allowed because we're saying whole over part equals whole over part. I don't recommend you do that unless you totally understand what you're doing, but number 1 is a true statement. 3 is false because AB is to BC as EB is to DC. That's saying whole is to part as whole is to whole. That is not okay. The part, this one does not belong. And so we would want to change number 3 if we wanted to make it true. We would need to say AB is to AC as EB is to DC. The other 2 are correct because the corresponding angles are congruent, so we know that this is parallel, and angle E goes with angle D, angle E goes with angle D, so the only false one was number 3. Geometric mean, how did y'all like this homework? Was it pretty straightforward? Wait, so you can assume they are parallel? I had already gone over that one, Karthik. I was just reiterating it. Yes, you can assume they're parallel. When 2 triangles are similar and one's inside the other like that, then those lines are going to be parallel for sure. They were similar. Yeah, the directions said they were similar. Yeah. Okay, which ones can I go over from this homework? Let's pick 2, no more than 2. The thing about geometric mean is that you have to memorize those proportions. No, we're not going to give them to you on the test. Not only do you need to memorize the proportions, but you have to memorize what problems can I use geometric mean on and what problems is it inappropriate to use on. So I'm doing number 11. And 12. Okay. Let's get started. 11 and 12. So number 11, we are solving for 3 different things. What I would do first is I would solve for x first. Let's solve for x first. Okay, so to solve for x, I'm going to use the proportion that says, oh, is it going to let me write? Segment 1 over the altitude equals the altitude over segment 2. Okay, this is a segment of the hypotenuse. This is a segment of the hypotenuse, and this is the altitude. All right, so segment 1 is x, the altitude is 6. Oh, the altitude is still 6, and segment 2 is 9. You cross multiply, and you get 4. Okay, now I saw y'all typing in the chat that I told you not to use one of your answers to find one of the other answers. And of course you would not do that unless you had to. If you had to, then you would. Okay, so if you have to use one of your answers, you would. I also heard people asking if they could use Pythagorean Theorem. And right here, since they gave us this and they gave us this, then you can absolutely use Pythagorean Theorem to find z. I'm not using one of my answers that I came up with. I'm using what they gave me. So I totally would do Pythagorean Theorem to find z. 6 squared plus 9 squared, and then you take the square root. We haven't learned how to simplify radicals. That'll be next unit. So for our purposes, we'll just round. Z is 10.8. And then, I mean, since x was such a pretty number, it wasn't a decimal, I also don't feel bad using it to find y because it wasn't a decimal. It was an integer. But just for kicks, let's find y doing geometric mean, because why would we not practice more with it if we could, okay? So let's find y using geometric mean. Y is the geometric mean between the hypotenuse and the adjacent segment. The hypotenuse is 13, 9 plus 4, and the adjacent segment is 4. So yes, we are using one of the answers that we found. You're totally right. So then you would cross multiply the square root of 13 times 4, and we would get 7.2. Okay? Now we're going to do number 12. Number 12, let's see. Would we choose the proportion that deals with altitude or choose the proportion that deals with leg? Well, we don't know anything about the altitude. Nothing on the altitude is labeled. So we're going to choose the one that says leg. I'm not going to write it up here. I know you have it in your notes. So the leg is the geometric mean. That just kind of means that's the one that's repeated twice. The leg is the geometric mean between the hypotenuse and the adjacent segment. Hypotenuse over leg equals leg over adjacent segment. Now we're going to cross multiply. 12x equals, I'm going to go ahead and FOIL that right away. I'm not going to show my middle step. X squared plus 6x plus 9. Be careful. Make sure you have that middle term. You have to FOIL first, outer, inner, last. If you need to write it and set it up yourself, you can FOIL that. I can already tell this is a quadratic. So I need to move everything to one side of the equation. 0 equals x squared minus 6x plus 9. Because when I moved that 12x over, 6 minus 12 is negative 6. All right, now I'm ready to factor x. I need things that multiply to get 9. 9 and 1, 3 and 3. Well, I need to make a 6 out of it. So I'm not going to pick 9 and 1. I'm going to pick 3 and 3. I need a negative 6. The only way I can get a negative 6 with a 3 and a 3 is if they're both negative. Negative 3, negative 3. Luckily, when those multiply, the negatives will cancel and we'll get our positive 9. This is called a double root. Do y'all remember that? From algebra? X equals 3 and x equals 3. Well, we don't need to write it twice. X just equals 3. So normally when we have a quadratic, when it has a degree of 2, we get 2 answers. But in this case, our answer was 3 and it was 3. Positive 3 and positive 3. So we got the same answer twice, so we just need to write it one time. Okay. And you really need me to do 13. I'll do it super quick because we're never going to get to the cool thing I had planned for today. Okay, this is a leg. Okay, so we're going to use the proportion that calls for a leg. The leg is the geometric mean between the hypotenuse and the adjacent segment. Be careful, the hypotenuse is not 5x, it's 5 plus x. So be careful there. Okay, I'm going to go to town multiplying. Ready? X plus 2 times x plus 2 is x squared plus 4x plus 4. When you FOIL, x times 5 plus x is going to be 5x plus x squared. Because you have to distribute. Okay, the awesome thing about this one is that the x squareds cancel. And then you subtract 4x from both sides, and x is 4. Okay, I guess I'm doing one more. 14. You have to draw a picture. We did that in our notes yesterday. The segments are in the ratio of 1 to 2. You know when you hear ratio, you put an x on it. You attach an x to it. We've done that every time since the beginning of the year. The length of the altitude is 8. How long is the hypotenuse? So the proportion is the altitude is the geometric mean between seg 1 and seg 2. Remember that? Seg 1, seg 2, or seg and other seg. Okay, 8 times 8 is 64. X times 2x is 2x squared. Divide by 2. X squared is 32, and you take the square root of 32. It said, what was the length of the hypotenuse? It didn't just say what is x. So if we go back to that one, we get x is the square root of 32, 5.65 or whatever. But you have to plug it in here. The hypotenuse is 1x plus 2x. The hypotenuse is 3x. So you need to multiply it by 3, and that's how you get your answer on that one. It's actually 16.97. So like the 7 bumps the 9 up, which bumps the 6 up to a 17. The answer is 17. Let's do some whiteboard problems. Let's just discuss a few things first. 2 triangles are similar if, you know what goes here. Not even triangles. I'm going to say polygons. If their angles are congruent and their sides are proportional. Proportional. That's the foundation to the unit. You need to walk into the test intimately knowing that. Scale factor. What did I teach you about scale factor? I taught you second over first. So you grab a length of the second figure and you put it over a corresponding length of the first figure. In scale factor, the units have to match. So if this is 3 feet and this says, 15 inches, you are not done. That is not your scale factor. You need to convert them both to feet or both to inches. Your units will cancel because scale factors are unitless. Do you want to do this one? There's, 12 inches in a foot. So if I want to be all inches, I would say, 36 inches over 15 inches. The inches would cancel, and then we would make sure that we can't reduce that. 36 over 15 is 12 fifths. So that would be my scale factor. Yes, the units matter on scale factor. The units don't matter when you're cross multiplying, but they do matter if someone asks what the scale factor is. Good. Okay, solve this problem and I'll call on someone to work or to give their answer. For those of you who are kind of stuck, let me just start it off. This is just basic. This is honestly just algebra. This isn't really geometry. On this next one, I'm probably not going to FOIL that in my head. I'm probably going to write it out so I can FOIL it properly. X times 3x would be 3x squared. X times negative 2 would be negative 2x. Negative 1 times 3x would be negative 3x. And then negative 1 times negative 2 would be plus 2. Okay, we move everything to one side. So we'd have 0 equals 3x squared. Let's see. This is minus 5x, but then I'm going to do minus 10x. So it'd be minus 15x. And then 2 minus 20. The great thing about this is that every term has a 3 in it. So we can pull out a 3. 0 equals 3, parentheses open, x squared minus 5x minus 6. So I'm going to let you factor that. Got some interesting answers. Okay, the problem here is that you can, things that multiply to get 6 are 2 and 3 and 6 and 1. You can make a 5 out of a 2 and a 3. You can make a 5 out of a 6 and a 1. So you actually on this one have to be really careful. The problem here is that I can't do minus 2 minus 3. Because what happens when I multiply negative 2 times negative 3? Ooh, I get a positive 6. And we do not want positive 6. So I'm going to have to do minus 6 plus 1. That'll get me my negative 5 when I add them. And then I'll get me my negative 6 when I multiply them. You take the opposite of both of those x equals -1, you get that from here, and x equals 6, you get that from here. You may ignore the 3 is still there, but the 3 does not affect your answer. It never fails to baffle me how many times I go over this and how many times we can't do this. Okay, this just says solve for x. Did this say that it was a geometric mean? No. It's not a geometric mean problem, it just said solve for x. We need to write all the answers for x. So, oh, sorry, not 144. Sorry. $64, right? Sorry. Plus or minus 8. Most of you got 8. You didn't get the -8, so you would get it half wrong on the test on Friday. So just be careful about that. Next problem. Update your answer in the poll. If you got 54, you are correct. That's the answer. The ratio between the circumference of two circles is 3 to 5. Circumference is a length. Even though it's a circular length, it's just a length, so it is 1D, and that's all we care about. Find the area of the smaller circle if the area of the larger circle is 150. It's the larger one, so I'm going to put it in the denominator. Area is 2D. So I'm not going to cross multiply those, not going to cross multiply them. I need to convert everything to 2D because that's where x is. So I need to convert this bubble to 2D. How do you convert to 2D? Well, you square it. So 3 squared times 150 divided by 5 squared. Very good. The answer is 54. Let's move on. Okay, so sorry about the typo on that one. Let's see if it works this way. Okay, the base of cone A has an area of 4. The base of cone B has an area of 64. So this is 2D because it's area. The volume of cone A is 100 cubic meters. Volume is 3D, and we need to find this one. This is the toughest problem of this type because going from 2D to 3D is a two-step process. So first, we need to go to 1D. This is the only way to do it in this class. Next year, you'll find a different way to do it. The way to go from 2D to 1D is to square root. Square root of 4 is 2. Square root of 64 is 8. If you want to reduce that, you're welcome to. If you want to keep it as 2 over 8, that's fine. Now we need to go to 3D, so we need to cube it. So now I'm officially in 3D, and 1 cubed is 1, and 4 cubed is 64. This column is 3D, this column is 3D, so now we can cross multiply. And when you divide by 1, you're just going to get that same answer. So 6,400 cubic meters. We're doing a lot of these, if you can tell. The heights of two cones are 4 inches and 5 inches respectively. The volume of the larger cone is 3,375. What's the volume of the smaller cone? Heights are 1D, volumes are 3D. We need our answer to be in 3D, so we're just going to cube this. Now we're 3D, and now we can go straight to our calculator and cross multiply. 4 to the third times 3,375, enter, divided by 5 to the third, enter. 1,728. Oh, we got to put units. It's volume, so it's cubic inches. Ooh, next one. Good problem with crazy stuff going on, right? Well, first I would look at this problem and I would see these arcs. That means that this triangle right here is an isosceles triangle. Since it's isosceles, we know that this side is 10. And now I can set up a proportion. 3 is to 5 as x is to 10. The reason I was allowed to set up this proportion is because these two triangles are similar by angle, because those parallel lines. Yes, I'm doing whole over part equals whole over part, and you only do that with caution if you know what you're doing. 3 times 10 would be 30 divided by 5, so x would be 6. Alrighty. Next one. Alright, on this next one, you absolutely cannot do 27 over 9 equals 48 over x. Those do not match up. Those are not corresponding. So this is one where I would recommend finding this whole side so that your pieces can match. So we would say 27 plus 9, 36. And then I recommend you find this length, which would be, let's call this y, and then once we get y, we'll just subtract it from 48 to find x. That way we're not putting a subtraction problem in our proportion. So what is our proportion going to say? It's going to say 36 is to 27, because 36 is the side of a triangle and 27 is the side of a triangle, as 48 is to y. So this is the side of the large over the side of the small equals the side of the large over the side of the small. As long as you stay consistent, it doesn't matter which one you put in the numerator. So I'm going to do 27 times 48 divided by 36. Now if I choose to do it this way, get 36? If I choose to do it this way, I have to remember that that is this segment and that is not x. So now I'm going to do 48 minus 36, and then we get x is 12. So just be careful if you do it that way. Yes, Quan, yes. Okay. Next one. First thing I would do is put vertical angle markings. Next thing I would do is put markings for alternate interior angles. The reason I would do that is because that's going to tell me which sides correspond. So now what I'm going to notice is that 9 is across from no arc, and 7 is across from no arc. So there's my first ratio. There's my scale factor in a sense. There's my first ratio. I'm going to put second over first. You don't have to. 9 is to 7 as y is to, which one does y go with? Well, it's obvious. It's the one that goes vertical, straight up and down. So it goes with 13, the other one that goes straight up and down. They're both across from the single arc. So 9 times 13 divided by 7 is a nice pretty fraction. Just kidding, it's not pretty. 1/17. Now, we're going to use the same proportion again. On the test, you will use the same proportion again. 9 is to 7 as x is to 8. A lot of people get problems like this wrong because they put as 8 is to x. You have to look at what triangle you're starting with, and you have to start with that triangle both times. 9 times 8 divided by 7, not very many things are divisible by 7 very easily, and that's why our answers are fractions like that. But you know that we do that a lot. Please do not put your answer as a decimal. We accept fractions on this. Fractions. Improper fractions to be exact. All right, let's look at this next one. These two triangles are similar because I have a shared angle, so they're similar by angle. So now we can use all of our similarity postulates. We can set up proportions actually. To find y, you can do 12 is to 4 as y is to 5 as long as you're careful. To find x, you cannot do 12 is to 4 as y, 9 is to x. You cannot. So to find x, you would need to add these together. That would be 16. So you would say 12 is to 16 as 9 is to x. There's a difference between these two. And the difference is if you're going to do whole over part, you better do whole over part on the other side. That's all the time I have for today. Goodbye.